Hello dear friends, this is another lecture series, chapter number 26. The book name is Physics for Scientist and Engineer, Giancoli. Okay, so we start chapter number 26. The topic name is EMF and the potential difference. Let me define the EMF first. EMF is basically energy supplied by battery, energy supplied by a battery to one coulomb of charge or to a unit charge. So energy EMF is equal to energy supplied divided by charge. So the EMF is equal to energy supplied E divided by charge Q. Okay, so this is basically potential of the battery. So what is the EMF? In other words, in simple words, the EMF is the potential that the battery has, that actual or total potential that the battery can provide to the mean that how much energy it supplies to charge is called the EMF. Okay, let me explain in a more detailed way. So for example, if we have a cell or battery that has positive negative terminal, so if we connect with the voltmeter directly, so that suppose the voltmeter shows the 12 volt, so it means the 12 volt is the EMF of this cell, EMF of this battery. Okay, but as we know that this has the battery has also the internal resistance, because the battery has also some internal resistance. So actually in practically the battery has internal resistance with them. Okay, so if we connect, for example, if we connect another bulb, a light bulb with this battery, for example, light bulb with the battery, now we measure the potential difference across this bulb by using the voltmeter. So this will not be exactly equal to 12 volt. It must be 12 volt, but it's not exactly equal to 12 volt. But why? Because we know that the battery also has some internal resistance. So battery also has some internal resistance. These internal resistance is the resistance due to the battery components, because we know that battery has some electrolyte material, any other material. So there is an internal resistance between the cell or battery. So due to this internal resistance, there is a lost volts. Some potential is lost, that is known as the lost volt. So that's why this the bulb does not show the actual potential, that is 12 volt. So it means its potential must be less than the 12 volt. Okay, so what happens, why its potential is not 12 volt? Let's assume that, for example, this internal resistance small r is for example, this is value of this internal resistance is 0.1 ohm. It's very less, small potential. Okay, and the battery has potential of 12 volt. Okay, so that there is a lost volts, so how much volts are lost in this case? So we have to first remember the, for example, suppose that the current that is flowing through the circuit is 10 ampere. Suppose that 10 ampere is current flowing through this bulb. The 10 amperes is flowing through this bulb. Now we can find the lost volt across the battery. Let me redraw this diagram again. For example, this is internal resistance, this is the cell. The cell actual potential is 12 volt. That is known as the EMF. So this is internal resistance, that is 0.1 ohm. And external, when we connect any external, for example, we connect a bulb. So when we connect the bulb, and the bulb voltage is the when we want to know the bulb the potential across this bulb. Okay, so suppose that the current that flows through this bulb is suppose 10 ampere. Now we can find the lost volts. From here. How much potential is lost? Why this potential is across this is not 12 volt? Okay, so we can find the potential across lost volts. Okay, So the basic formula is EMF is equal to Vt is equal to E minus IR. This is the formula to find the terminal potential across this bulb. So Vt is the terminal voltage, Vt is the terminal potential that can be represented by the VAB, that can also be represented by VAB. So the VAB is equal to E minus IR. Okay, now we can find the VAB. If EMF is 12 volt, the battery actual potential is 12 volt minus current. The current flowing through is the 10 ampere and the resistance is 0.1 ohm. So that the VAB now is equal to 11 volts. So what does it mean? It means the potential across this bulb will not be equal to 12 volt. It must be equal to 11 volts. It must be equal to 11 volts. So what does it mean? It means that the battery supplies the actual potential of 12 volt, but this bulb does not receive the 12 volt, it receives 11 volts. Why? Because there is some volts that are lost, that is the 1 volt is lost across this internal resistance small r. So if this is energy conservation, the battery supplies 12 volt, 1 volt is lost against battery supplies 12 volt, 1 volt is lost against this internal resistance, and this bulb receives 11 plus 1 makes 12. So this is an energy conservation. So according to KVL, so this is all the potential must be the constant. The battery supplies the potential that must be the constant. The total potential is the sum of all potential drop across the terminals, across the instruments, or across the anything that we connect with the circuit. Okay, so 12 is equal to 1 plus 11. So that lost volts are, so we can say that lost volt means the volts potential lost across small r, that is equal to lost volt is equal to I current into small r. The current is 10 ampere and small r is 0.1 ampere. So it means only we can say that current is 10 ampere and the 0.1 is the internal resistance. So 10 multiplied by 1 by 10. So it means 1 volt is lost across this small r. So 12 battery supplies 12 volt, and EMF the lost volt against the resistance is 1 volt, and the bulb drops 11 volts. So the 11 plus 1 makes 12. So there is the energy or potential conservation. So the formula is Vt is equal to E minus IR, or EMF is equal to, or in other words you can say that EMF is equal to Vt plus IR. So this is what these formulas are used in the next section. Okay, thank you.